Alright, so today we'll be covering the mean value theorem. So the mean value theorem, the definition of the mean value theorem is if f is continuous on the closed interval ab and differentiable on the open interval ab, there exists a number c in ab such that f prime of c equals fb minus fa all over b minus a. Alright, this seems a little confusing at first, but once we do some problems with it, it'll make complete sense. Alright, so let's do number 1, this problem. Given f of x equals 5 minus 4x, find all the values of c in the open interval 1, 4 that satisfy MVT. Alright, so let me just write, I'm going to take the paper away. Let me just write down the, the equation f of x equals 5 minus 4 over x. And we want to find all the values in c in the open interval 1, 4. Alright, so now the first step is we need to check if f of x is continuous on the closed interval, 1, 4. Now, we know it is continuous because the only time that x is not continuous is if x equals 0, because that makes this f of x undefined. But we know that 0 is not even in the interval, so we know for a fact that it's continuous. But now we need to see if f of x is differentiable on AB. So let's, but we know that it is differentiable on the closed interval of not AB, 1, 4. We know that it's differentiable because if we do take the derivative of f of x, you're going to get 4 over x squared using the quotient rule. And we know that the only time x is going to be undefined in the derivative is if it's 0, and 0 again is not in the interval. So we're good. Now let's evaluate f of a and f of b. So we know that 1 is a and 4 is b, right? So let's do f of 1 equals 5 minus 4 over 1 equals, and that equals, okay, so minus 4, obviously this is 1. And then f of 4 equals 5 minus 4 over 4 equals 4. Sorry, I'm just being, and then yeah, so that's 1, 4. All right, so now that we have that and we have the derivative, let's use the equation. Let's use the MVT equation that they gave us. F prime of c equals fb minus f of a equals b minus a. So if we plug that all in, let's plug in f of b and f of a. We already figured that out. We figured out f of 4 is 4. I mean so it's 4 minus 1 all over 4 minus 1. And we get 1. Alright, so that's simple enough. Now we set this 1 equal to your derivative, because basically f prime of x and f prime of c are the same, you can set them equal to each other because they're basically the same thing, because x is equal to c. They just change the variable. So we're going to set 4 over x squared to equal 1, and we're going to move x squared to this side because x squared times x squared, and you're going to be left with x squared, and then 4 equals x squared, and obviously that's x equals plus or minus 2. Wait, but that's not your answer. We need to find when the c, right? And you know that -2 can't be in the interval because it's only 1 to 4. So you know that c equals 2, not -2. And that is your answer. All right. Now let's do a problem with trigonometry. Let's do, given f of x equals sine x, find all the values of c in the open interval 0 to pi that satisfy MVT. Alright, so f of x equals sine x, and then you want to find all the values of c in the open interval 0 to pi. Alright, so now let's first of all, do you remember our first step? We need to see if f of x is continuous. We know f of x is continuous because sine of x will never be undefined in 0 to pi at all, because it just won't if you used a unit circle. And it will never be, if you take the derivative of sine of x, you're going to get f of x equals cosine of x, And in cosine of x, if you plug in any number from 0 to pi, you're not going to get undefined. So you're good. So you know for a fact that that the MVT rule will work. So now let's evaluate a and b, which is a and b again. So f of 0 equals sine of 0, which equals 0. And then f of pi equals sine of pi, which again is 0. So that's pretty simple. Now let's find f prime of c, which we know that it's f. We know it's f of b minus f of a all over b minus a, and we know that f of b is 0 minus 0, which is f of 0 here, all over b minus a, which is pi minus 0, and we're going to get 0. So now we set 0 equal to our derivative. Cosine of x equals 0. So if we look at a unit circle, we know that cosine of x equals 0 at pi over 2, because it's 0, 1. And we know it's also equals 0 at 3 pi over 2, but we're only looking for when it equals 0 between 0 and pi. So we know that x equals pi over 2, and that means your c equals pi over 2, because that's in the interval. So c equals pi over 2 is your answer. All right, now let's do one more problem, and let's make it a word problem. Let's use the MVT using a word problem. All right, so we're gonna use, this is last problem. Two stationary patrol cars equipped with a radar are 10 miles apart. As a truck passes the first patrol car, its speed is clocked at 60 miles per hour. 8 minutes later, the truck passes the second patrol car. Its speed is clocked at 55 miles per hour. Does the truck exceed the speed limit of 60 miles per hour during those 5 minutes? All right, so now we're going to use MVT in this, and we'll be able to figure out if the truck exceeds the speed limit of 60. So let me just I'm going to take the question away. I'm going to write out everything we know. So we know let's use this first patrol car and then the second patrol car. All right, and right here we know that it's 8 minutes. That's how far apart they were, 8 minutes apart. No, sorry, what am I saying? Not 8 minutes, 10 miles apart. What am I saying? Yeah, 10 miles apart. All right, now we know that the truck at 1, it was going 60, and we know mph, and we know that at 2 it was going 55 miles, and it went in those 10 miles it went 8 minutes, and we want to convert 8 minutes to hours, so we're going to put 8 over 60 hours, because what's it called? We want to do 8 over 60 hours, because we want to have it in hours, because we're doing miles per hour. So that's your time. All right, so now we're going to have s of t equal distance. That's going to be that's what we're going to use, or that's what we're going to signify distance as, s of t. And we're not going to even look at the 60 miles per hour and the 55 miles per hour till the end. So all we need right now is the 10 miles per hour and the time. All right, because that's the only thing that matters in your equation. F of c equals f of b minus f of a all over b minus a. Now you're probably wondering, what's your b and a? Okay, so your a is going to be it's going to be 0, because you're at 0, like at your distance at a is 0. You're not, like, that's the car. I mean, that's what the truck is. Like, its distance is 0. Not its distance. Oh my gosh, sorry. Its time is 0. Sorry, its time is 0. But then at b, its time is 8 over 60 hours, right? And then at 0 hours, the truck is also, so f of a if the truck is also at 0, because if it's at 0 hours, it's not moving. And then at 8/60, at 8 minutes, or at 8/60 hours, it's going to be 10 miles. So the truck had moved 10 miles in that amount of time. So now that we know our variables, we're going to plug in all that into the problem. We're going to plug it all in. So we're going to get equals 10 minus 0, 8/60 minus 0. And because I'm doing my math on a calculator, 10 over 8, if you do 10 divided by 8/60, you're going to get 75 miles per hour. So that is going to be your answer. I mean, that's going to be your f. That's going to be your derivative f. So, and this means your this equals s of t. Sorry. So no, yeah, it equals your speed. Sorry, f prime of c equals your speed, because s of t is your distance. So s prime of t is your speed. And I'm sorry about that. This is s, and then this, yeah, so that would make sense. So f prime of c is, so f prime of, and this is t. Yeah. All right, so now you know that 75 miles per hour exceeds the speed limit of 60 miles per hour. So you know for a fact the truck did exceed the speed limit and he deserves a ticket. And that is it.